page 189, question number 135. The plane heads on a bearing of 040, so 40 degrees, it heads off this way and it travels for 320 kilometres. Once it gets to the top here, it turns on a bearing of 130 degrees and travels for another 160 kilometres. The question says, what is its distance and bearing from the start? So obviously the distance is that length there. Now I can see that there's a 90-degree angle being drawn in here, so we can clearly use Pythagoras and trig. Let's assume that 90-degree angle wasn't drawn in there, and we'll just see how we could have worked that out. As I've always suggested, make the lines longer. You can see a pair of parallel lines there. And because they're parallel, this angle is 40, this one must be 40 as well, because they're alternate angles. And if this angle here is 130, then this angle in here must be 50, because the angle's on a straight line. So clearly we can see that this is a 90-degree angle. You're not always told that, and sometimes you're going to have to work that out for yourself, doing exactly the way I did it there. Right, because that is a 90-degree angle, we can use Pythagoras' theorem to find the distance here. This must be the hypotenuse, the longest side, because there's the right angle, so this one is clearly the hypotenuse. So x is going to equal the square root of 320 squared plus 160 squared, close the brackets, working that on a calculator. We're going to need some rounding. 357.8, that's in kilometres, and I've given my answer to correct to 1dp. Right, now we need to find, there's always an and, now we need to find the bearing of the plane from the start, and of course the from is the indicator where we're standing, so we're standing here. We begin by facing north and turn ourselves clockwise around to the direction of the plane. So turning around here, there's the plane out here, so I want this bearing in here. I've got 40 degrees of it, so we'll need to find this angle in here using some trig. I could use x, but just in case I've made a mistake with x, I'll use the 320 and the 160. So this would be the opposite side, adjacent. We're looking at tan theta, TOA, opposite over adjacent. So that means theta will be tan to the minus 1, tan inverse. We could do some simplifying there because it's clearly a half, but you can also let the calculator do the work. Need to check, of course, that we're in degrees. And on the calculator I get 26.56505. I'm going to write all those down because I'm not ready to finish my answer yet. Now the bearing needs 40 added onto that for the bearing. So the bearing will equal 66.56. Now bearings are usually given with 3 digits, so we're going to need a 0 in the front. And we'll do some rounding on that last one, which will round the 6 up to a 7. And that's correct to 2 significant figures. The 0 in the front is not significant, although needed for a bearing if you're going to give it in 3 digits.